You're welcome. Today, we're doing all of chapter 12. Good news is, to do chapter 12, all you need is your calculator and to pay attention today. So take out your calculator, yeah. Okay. Yeah, where's yours though?
Mine is, that's a great question. I'm going to figure that out.
Yeah, it'll come in handy. I don't know. Yeah, it looks like it.
Thank you.
All right. So we're going to start with just a couple of quick definitions. There's a charger up on the power strip here. So we're going to start by defining what we call a polynomial function. So a polynomial function has like some coefficient, x to some power, a new coefficient, x to some power that's one less, et cetera, all the way down until you get to like a constant term, right? These a's are just what we call the coefficients. The x's are the variables, and the exponents we call the powers. When talking about a polynomial, oftentimes we classify it by its degree. The degree for a polynomial is the biggest exponent on a variable. So this polynomial that we've written right here would be a degree n polynomial. Keep in mind, for a polynomial, the exponents must be positive, I should say non-negative whole numbers. Can't have negatives, can't have decimals, can't have fractions as exponents. And then, so this guy right here that has the biggest exponent, we call the leading term. And so the coefficient on that leading term, we call the leading coefficient. Right? This should all be a review from last year, vocab-wise. So let's take a look at some examples here. First things first, we'll decide if this is a polynomial or not. And if it is a polynomial, we're going to give the degree and the leading coefficient. So take a look at A. F of x equals 4x to the 6 minus 5x squared plus 2x minus 1. Is that a polynomial? Yes or no? Nobody knows? Negative where? It is a polynomial. Why is it a polynomial? The coefficients are all real numbers. Sure, that's fine. What else do you have to have? The exponents must be positive. We really want to say non-negative because 0 is okay. Whole numbers. Do we have that? And there's no other weird operation going on like square root or logarithm or sine or whatever. Everybody agree? So yes, that's a polynomial. What's the degree? We said this like 2 seconds ago. Thank you. And the leading coefficient is 4. Good. Let's take a look at B. Is B g of x equals square root 3 times x minus 6? Is that a polynomial? What do we think? Yes or no? Huh? What are you saying?
Like there's the square root.
Well, the square root of 3 is just a real number, isn't it? Is the square root extending over the variable?
Yeah.
Is it?
No.
Look at the picture.
So it is.
So this is a polynomial. It is a polynomial. Now, if that square root symbol had extended over the variable, now it's not a polynomial. But the square root of 3, that's just a real number. The exponent on the x is just 1. That's fine. What's the degree for this polynomial? Not 0. 1. Why is it 1? Because I know that's x the first, even though we don't write the 1 there. We know it's there, right? And what's the leading coefficient? Square root 3. All right, h of x. Is that a polynomial? No, why not? The square root is over the variables, right? Or a variable even. It doesn't even have to go over all of them. It just has to go over 1. So don't worry about degrees for things that aren't polynomials and leading coefficients for things that aren't polynomials. How about d? Is that a polynomial? No, why not? We have a negative exponent. Do you guys feel okay about polynomial, not polynomial now? Better-ish? It's easier to spot the things that aren't than the things that are, right? In general, if the only things going on is like addition, subtraction, multiplication, and an exponent, as long as those exponents are whole number and positive, you're in good shape. All right. So oftentimes when we name a polynomial, we name them according to their degree. So for example, if we have a degree 2 polynomial, that means it has like an x squared in it. We call those quadratics. Right? You remember that from last year? You have a degree 1 polynomial, where it's just like an x in it. We call those linear. If you have a degree 0 polynomial, where there's no x at all, well, that's just a constant. If you have a undefined degree, that's just the 0, which is a 0 function. That's just some naming. Everybody's okay with the idea? So just naming by degree. Degree 2 is quadratic, degree 1 is linear, degree 0 is constant, undefined degree is 0 function. No big deal, right? All right. The next thing that we want to do is talk about the relationship between two variables. Typically, just for the sake of argument, we'll call them x and y. We can measure the linear relationship between two variables with a number called the correlation. We abbreviate correlation with the letter R. So R is going to be a real number between -1 and +1. If R is a negative value, that means we have negative correlation, i.e., we have like negative slope in the linear relationship. If we have positive correlation, if the R value is positive, that would mean we'd have positive slope in our linear relationship. The closer we get to 1 or -1, the stronger our linear relationship becomes. So really from 0.9 to 1, or from -1 to -0.9, we'd say that's a very strong relationship. Up to, say, maybe 0.7. We'd say that that's moderately strong. Anything kind of on the others, or between -0.7 and +0.7, is weak correlation, except for 0, which means we literally have no correlation at all. Closer you're getting to 0, the weaker that linear relationship's becoming. Does that feel okay there? So just kind of telling us how we're going to use that number. We haven't talked about how to calculate that number at all. Special word about if you actually get a value of a correlation of -1 or +1. In that case, what that means are those xy's would all fall on one specific line. It means that your data is perfectly linear, that the points, the xy's you're looking at, form a actual line. They would be points on one single line, right? Anything else than that, it's going to resemble a line, but it wouldn't be exactly a line. You guys get what I'm saying there? Okay. Okay, so let's look at a little example here. All right. So let's say we have this right here. What is this plot set of points called? Do you remember what this is called? Scatter plot is correct. Good memory. So if you got a scatter plot right here, we're asked to describe the correlation. So good. Nathan says that's negative correlation. How can you tell it's negative? Because the data is trending down as we move from left to right. Now, we also need to describe the strength of this relationship. So like very strong, moderately strong. Yeah, I would accept like moderate to very strong. I think either of those are appropriate. You're probably right on the border. Yeah, that's all we can do right now. So I'd say moderate to very strong. And that said to give an estimate for the R value. So if we know that moderate to very strong kind of lives here, the R value we might guess would be, yeah, something between -1 and -0.7. I would mark anything in that range correct. So -0.8 sounds lovely. Got to make sure you remember to put the negative sign though, because we said it was negative correlation. What do you guys think? Is that okay? There's nothing really to do there, right? We're just kind of using the vocabulary. All right. Now, one thing that we're going to be interested in doing is if our data is sufficiently linear, what we're going to want to do is build a line of best fit to approximate this data so we can use it to make predictions. To do this, we're just going to use our calculator to do the whole dang thing. Take out your calculator, turn it on, focus in and follow along. I'll show you how to do this. So the data that we're given relates to the price of a canned good and the number of that canned good we're selling in a day at like a shop. You're noticing as the price gets lower, we're selling more cans, right? All right. So the first thing that we want to do is we want to get this data into our calculator. So I'm turning my calculator on, and I'm going to press the Stat button, which is right next to the left arrow. From the Stat menu, I'm going to want to be on the Edit tab and select the Edit command. Now I have data already in my calculator. If you have data already in your calculator and you don't want it anymore, to get rid of it, you're going to move your cursor. See how my cursor's right here on 6660? I'm going to move my cursor so that it's on the heading, L2. Press the clear button, not the delete button, and then the down arrow, and that'll wipe the entire column. So now I'm just going to move my cursor back up onto L1, press clear and then down, wipes the whole column. If yours was all empty, you didn't have anything to do. I'm now going to type in the price of my cans into L1 and the price of or the number of cans into L2. So go ahead and do that right now. You press enter when you've typed the number in to move to the next cell. Everybody okay so far? I'll take by your silence and the sound of buttons being pressed that everybody's so far doing okay. Huh? It doesn't matter right now. Okay. Before I move on to the next thing, what am I going to do? I'm going to just double check to make sure that I typed everything in correctly. It's very easy to fat finger a number or to skip a number. You know, like just take a second, make sure that you typed everything in correctly. That saves yourself a load of hassle later on. All right. Now that I'm positive I typed everything in correctly, I'm going to exit out of here. I'm going to press the blue second button and the mode button, which is right next to it. And what I'm going to do now is look at my scatter plot. So to generate a scatter plot, I'm going to press second and the Y equals button. That opens up the Stat Plots menu. From there, I'm going to pick Plot 1. Literally listen to what I am saying instead of talking to your neighbor, and you would hear what I tell you to do. I don't want to have to repeat myself 40 times, and I'm trying to go reasonably fast because we don't have 90 minutes today. I press second and Y equals. You're welcome. Turn that on. So we're turning on our stat plot. The next option asks for the type. To make a scatter plot, that's the first option. We're not going to do any of the other options in this class. If you take a stat class, you probably will. I'm going to use the price as my X and the number of cans sold as my Y, because to me it definitely seems intuitive that the number of cans sold depends on the price, right? So I typed my cans into L1, and I typed, or my price into L1 and the cans into L2, so that's already set the way I want it to. If it wasn't, notice above your numbers 1, 2, 3, 4, 5, and 6 in blue, it says L1, L2, L3, L4, L5, L6. So if you needed to change those, if I wanted L5 here instead, I'd press second and the number 5, and that would change it to L5, but I don't really want to do that. I liked it at L1. And then the cursor or the mark that I'm going to make for my point is the square. I like using the squares because they're easy to see where they're at. All right. I'm going to exit out of here now, so second in mode, back to the main screen. And I'm going to press zoom, and I'm going to pick stat, which I think is option 9. Zoom stat, yep. So there's what your graph should look like. Everybody get that? It's okay? Great. If I look at that, does that look pretty linear? Yes. That's because you either are trying to enter in a blank list or you mistyped your list and have a different number of X's than you do Y's. So either you didn't type them into L1 and L2 when you went into the stat, or you mistyped something and you forgot to put one of the numbers in. One of those two things are happening.
When I click zoom stat, it just takes it up.
Nope, because you didn't press the zoom button. You pressed zoom and then you press the stat button. You pick zoom and the option is zoom stat. Avery.
Oh, okay.
So like
I see.
there's an option that says zoom stat or Z stat or whatever. There, zoom stat, number 9. Yeah, Grace. What kind of error?
Like it says quit with syntax.
Okay, that means if you go in your Y equals, you have some gobbledygook in there. So just clear anything out you have in your Y equals menu and press graph again, and it should be fine. Okay. So we have our scatter plot, right? That's lovely. Looks pretty linear. Wouldn't it be nice to get the R value for this before we move on and try to make a line out of it? What do you think? Just to confirm that it's as linear as it looks? That's probably a good idea. So press second and quit to move back to the main menu. What we're going to do now, you should have to do just one time on the calculator you're using, unless your memory gets reset or your battery dies and it like clears your memory or whatever. But usually we should just have to do this one time. But if you don't have your calculator here, you'll have to do it again on your calculator. We're going to press, we're looking for the command called diagnostic on. To find that, we're going to go to the catalog. So we'll press second and then the 0 button. The catalog is a list of every command on your calculator listed in alphabetical order. The command we want is diagnostic on, starts with a D. So we could scroll all the way down there, but that's a lot of scrolling to do. You might notice above lots of your buttons are little letters in green. If you find the little green letter D and you press the button under that, it'll skip you all the way down to the D's. That saves you a lot of button pressing if you know what you're looking for. So we should find the command diagnostic on in that list. Once I've located that command, I'm going to press enter. That's going to put it onto the main screen. And I'm going to press enter again, and it should say done. That should be the last time you have to do this, unless your calculator memory gets reset for whatever reason. Everybody's good? Okay, next up, I'm going to ask the calculator to give me the R value, and at the same time, it's also going to give me the equation for my line. So the process of getting an equation to model some data is called regression. So there's other types of regression other than just linear, although that's what we're going to be doing right here. How you do that is immaterial to us. The calculator is going to handle doing all of it for us. We just have to ask the calculator to do it. All of the regression equations live in the stat menu. So press the stat button. And then you're going to move to the calc tab. And if you look at our list, I see linreg, reg is short for regression, quadreg, cubic reg, quartic reg. I keep scrolling down. Linear reg again, lnreg, that's logarithmic regression. Exponential reg, power reg, logistic regression, sign regression, whole bunch of them. The one we want is that first linreg command number 4. So go ahead and select that. Now this requires 4 inputs for us. To do this, the calculator needs to know 4 things. It needs to know, where did you put your x's? Well, I put mine into L1. That's probably what you guys all did. So make sure that says L1. If it doesn't, do second and the number 1. It'll put the L1 there. We put our y's into L2. With what we're doing in this class, we will never have a frequency list. That will always be blank. And the last option is to store this regression equation somewhere so we can use it. I would like to do that because we're going to use this equation to do some stuff in a second. So the place you'd want to store it is into one of the y equals spots on your calculator so that we can graph the equation or we can plug stuff into that equation and it's easy to do. So I'm going to plug mine into y1. To get the y1 there, I'm going to start by pressing the vars button, which is right underneath the down arrow. Since we're looking for by the way, vars is short for variables. Since I'm looking for a y variable, I'm going to move over to the y vars tab. In this class, our calculator will always be in function mode. And there's the y1 that I was looking for. And now I'll press calculate. And the calculator does this. So we should all gotten the exact same numbers because we all use the exact same data. So what is this telling me? The calculator is saying, hey, here's the equation for a y equals ax plus b. Right? That's the equation for a line. You guys recognize that? It says my a is negative 104.6857143. That's the slope. The b, the y-intercept, is 329.2857143. That's the y-intercept. And look at this down here. The r value is my correlation, 0.96, yada, yada, yada. That's pretty darn good, right? Everybody feel okay with how we got there? So far, anyways? Take a look press the y equals button, take a look at what you see. What is this in y1? It is that equation that the calculator just generated for me. It copied it in there for me so I didn't have to type all of those stinking decimals in there myself by hand. Ooh, that saved me a lot of time. Avery.
When I pushed the y bars tab in the function, it took me back to the x list that.
I don't think you pressed what you thought you pressed. We'll do it again in a few minutes. No big deal. All right. So if we hit graph, now you see that the calculator's put in the best fit line for us. Hey, that's pretty nifty, right? Everybody feel okay with that? Let's say we wanted to know, we're asked to predict how many cans we'd sell if we charge, let's say, $1.80. What am I doing that? What am I really asking to do there? I want to plug $1.80 into the x of that equation that I just built, right? Well, that's lovely. The calculator can do this for us. Want to see? Because it's a lot easier than doing it by hand, right? So I'm going to exit back to the main screen. So second mode. And now I'm going to go in and retrieve that y1. So where was the y1 live? I press vars, and then what? Go to y vars, and then function, and then y1. Now, the calculator, if there's something in that y1 slot, I can use it like function notation. So I want to do y1 of 1.80. So what that's doing, that when you put a parenthesis around it next to the y, it's saying I'm going to take 1.80 and plug it into that equation in y1. So this is saying we're predicting to sell about 141 cans. Is everybody okay there? Notice that 180, $1.80, lies in between the set of datas that I used to build this model, right? Can you guys see that? When I do that type of problem, this is called interpolation. If we ask to do the same problem, if we want to predict how many cans we'd sell if we charge $3, that's the same thing, right? So I just do y1 of 3. I'd get about 15 cans. This is called extrapolation. Which one of these is going to be more reliable of an estimate? Interpolation, right? What can happen with extrapolation? What if I did $3.50? Look what happens. What's that saying? You're selling negative number of cans. Does that make any sense at all? No, because what's going to happen if the price gets too expensive? What's the least amount of cans I can sell? 0, right? So at some point it just stops, and it just stops selling cans, right? So when you do extrapolation, you can run into stuff like, sure, it behaves like a line for a little while, but eventually something else starts happening because this is the real world. And if things get too big or too small, weird stuff tends to happen, right? Is everybody okay? All right. What if I instead asked, what if I ask you instead to predict how much to charge to sell 100 cans? We're plugging 100 in for Y, right? And then solving for X. Our calculator can do this for us also. Let's show you the easiest way to do that. What I'm going to do is I'm going to press the Y equals button. And I'm going to put 100 into Y2. That's the Y value I want to solve, right? I'm plugging that in for Y. And I'm going to hit graph. What X value am I looking for? The intersection of Y equals 100 with my best fit line. How do I find an intersection of two lines again? We just did it. Second, and then the trace button. And then which command do I need? Good. Command 5, the intersect command. And now I just have two things in my Y equals menu, right? So first curve, that's the diagonal line. That sounds good. Second curve, the horizontal line. That sounds good. The guess, it doesn't matter because how many times are these two lines going to intersect? Just once. So there it is. I should charge about $2.19. Everybody's okay with that? Everybody okay? Still doing good? Okay. Now, there are other relationships other than linear, right? You could have a quadratic relationship. What's a quadratic relationship going to look like? What's the graph of a quadratic look like? You should remember this from last year. You guys, I swear. Looks like a U. Might be upside down. It's okay. How about exponential? What's that look like? Starts out slow and then gets steep real fast. What about cubic? It's going to look kind of like that. What about like something like that? That's probably going to be a power function. And that's one that maybe we don't recognize. Those other ones are ones we would have talked about in our Algebra 2 class. But we probably haven't talked a lot about power functions. Maybe if you're in the honors class for Algebra 2, you did briefly, but probably not in the regular one. So let's talk about what we mean by a power function. So power functions can be written in the form f of x equals k times x to the a. Mr. Kulik, isn't that just a polynomial? Well, here's the deal. For power functions that a, the exponent, it can be negative, and it can be a decimal. A could be any real number. I should say any non-zero real number. So we refer to a as the power of our power function, and the coefficient here, the k, is our constant of variation. So in words, a power function, we say that the y varies with the 8th power of the x. So let's look at some vocab or like word examples so you can kind of see this in real time or see this in action. So if we say the circumference of a circle varies with the radius, well, that tells me that like c is equal to k times r to the first. Now, I remember from geometry that the circumference of a circle is 2 pi r. So that 2 pi is my constant of variation, and the exponent on my r is the power for the power function. Is everybody okay there? If I also go back to geometry, it says the area of a circle varies with the square of the radius. So I know that a is equal to k times r squared in my power function model. And I remember from geometry that k has to be pi because area is pi r squared. So my constant of variation is the pi, and the 2 is my power. For my chemistry, oh, here we go. It says the volume of an enclosed gas at a constant temperature varies inversely with the applied pressure. You might recognize that as Boyle's law. It's why when you're like deep sea diving, you have to exhale on your way up so your lungs don't explode. Because you have pressurized gas down low under the ocean. If you don't you're coming up to the surface, the pressure decreases, so the gas expands. If you don't exhale, the gas expands and like explodes you from the inside. Cool, huh? Anyways, that's Boyle's law. So we'd say that V is equal to K times P to the negative 1. Yes, sure. How did I get the negative 1, though? Inversely. Inversely is words for negative 1. So the K is our constant of variation, and the negative 1 is our power. Everybody's okay? All right, let's do another before we do that, so how do I choose between which one of these models to do, right? I could look at the scatter plot and kind of use my eyes. I could think about the real life situation, think about what makes sense. But another way we can do that is, or another thing we can do is use what's called the coefficient of determination. Which is the R squared value. Remember when we did the Lin reg earlier, we got an R squared and an R value. R squared goes from 0 to 1. The closer you are to 1, the better the fit of your data to that particular model. So the R squared allows us to compare, say, a linear model to a quadratic model and make a decision about which one maybe is the better fit. And that's a numeric measurement as opposed to like, I'm using my eyeballs. This one looks... Here we have that's what we should do. Is everybody okay with that idea? All right. Let's do an example. So we're going to give you a new data set. And we're going to do this process kind of all over again that we just practiced. Except this time we're going to be asking you to do a different type of regression, but that really doesn't change a whole lot from our end other than we pick a different regression on our calculator. But like whoop-de-doo, that's just like a different option in a menu. So it says, consider the given data table. Use the data to create a scatter plot. Stop there. Let's do that part first. Get your calculator out. Let's start putting our scatter plot together. Where do we go to enter the data into our calculator? Stat. Very good. Then what? Edit. And then how do I get rid of the data that's already in there? I move my cursor to the name of the thing. Clear and then down. Don't press delete. You can delete individual cells. Like if I want to delete the number 52, you can delete that. Don't delete a list. Makes it a pain to get it back. All right. So away we go. Start typing. If you have a question about what to do or what to press, ask your neighbor. They might have been paying more attention than you were. That makes sense, right? Everybody's like, that's not surprising.
You have to clear on, go on L1 and hit clear,
And then down.
and then down. And go on L2 and clear.
Are you on, is your cursor on the L2? Your cursor literally has to be on top of the L1 or the L2. There's my scatter plot. The next thing on the question says, and create a power regression curve to model the data. Okay, I'll exit out of here. Where do I go now to create a regression? Stat. And then where? Calc. And then which one am I looking for?
Line reg number 4. Number 4.
No, it says create a power regression curve. So we want a different regression. Instead of lin reg, we want power reg. We're just reading the direction on the question, right? So the regression equation could be different in the question. Oftentimes they will tell you, I type all my stuff into L1, L2, then I'm going to store this into Y1. How do I get the Y1 there? Yep, then what? Yes. 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 Sounds good. So there's our regression equation. We all should have gotten the same thing because we use the same data. If you press the graph button now, you'll see that it fills that in for us. Look at that nice, beautiful fit there. The last part of the question then says, use the curve to estimate the orbital period of Neptune, which is 4,497 gigameters from the sun. So that is going to be an x value that we want to plug into our equation, right? Notice all our x's are gigameters. How do we do that? I exit to the main screen, and now I want to do y1 of 4497. So I just need to retrieve that y1 again. How do I do that? Vars. Y vars. Function. Y1. And then I'll do parenthesis 4497 and press enter. Woo! Look at that big number there. You know what that is? It's how long a year is on Neptune. 60,150 days. Takes a long time, right? Neptune's real far from the sun. It's a long trip around for Neptune. Yeah, it's like a whole lifetime in 1 year, right? What do you guys think? This is it. This is chapter 12. Like you're literally like just using your calculator to do stuff or answering some vocab questions. Do we have to do any manual mathematics here? No. Not really, right? Like you have to use some vocabulary. You have to use your calculator to get some numbers. But like literally we're not even typing things really immediately into our calculator, like doing calculations on it. We're just saying, calculator, do this. Calculator, do this. Calculator, do this. That's all of chapter 12. At this point, you guys should be able to do 1 through 31.
What does that do?
This is going on the
Sure.
No.
This is going on the note card.
Sure.
This is going on the note card right here.
So like whenever.
On and a half.
Yeah, sometime between then. It's fine. Now and then. Whatever. I'm not checking things over break.
It's not exactly right. It's like pretty close.
Hold on, though, guys. This was all of chapter 12, right? So you know what's going to have to happen soon.
No.
Is it next? That next.
Homework quiz needs to happen first, right? What should you expect next class? What else am I going to ask for?
No card on Friday.
Note card. Yeah. Send me a picture. Send me a picture is fine.
Do Friday?
Yeah. Guess what we're going to do when we come back from break? Chapter 12 test. It's the plan for right now.
Send it over.
Yeah, but then
We have a
today's a
meeting.
meeting, or tomorrow, Friday's a meeting, so it'd be Monday would be an 8 a.m. I know.
Everybody okay? You get the rundown here? Hi, Grace. What's happening?